Everybody, welcome to the podcast. In today's episode, my guest is Casey Bowman. Casey is a seasoned software developer and a full-time Bitcoin engineer. We've actually met each other a few years ago back at our previous job, but what really has struck me the most about Casey is his love and continual passion for Bitcoin and cryptocurrency in general. We talk emphatically about Bitcoin in the chat, everything from what it is, how it works, what it's all about, what its future is, what the blockchain is. So for those who are interested in Bitcoin or cryptocurrency, I think this conversation is just for you. So with that, I really hope you enjoy the chat. And remember, if you like these videos, if you like these podcasts, please don't forget to subscribe. I really do appreciate it. And with that, I really hope you enjoy my chat with Casey Bowman. Hello, Casey. How are you?
Hey, Barry. Very well, thank you. How are you doing?
I'm doing well. Thanks for joining the call. I know that we were just speaking about a bunch of things before, but I appreciate you coming on and sort of telling us about yourself. But I want to let you sort of introduce yourself a little bit, because I know we have a lot to get in. And I should preface this conversation by letting everyone know that we are friends. We've been friends for many years now. And so we might go off at little tangents here and there, but I hope that we'll keep the conversation sane, productive, and as informative as possible, because I think a lot of people are, as far as I know, I'm interested in what you guys are, what you're doing with Bitcoin and what have you, and sort of your dealings with the Bitcoin community and just cryptocurrency in general. So I really want to hear a lot about what you have to say. But before we all do that, let's get into a quick 1 minute intro about yourself.
1 minute?
Yeah, 1 minute. Or if you want more, go ahead.
Okay, 2 minutes. We'll see. But anyway, so my background is I became interested in the idea of how to have a better theory of money back in grad school at Stanford. I was in a department called Engineering Economic Systems. And there, I was sort of thinking about using a monetary theory, but I just didn't find one that was very satisfactory. So that's been a passion of mine then and since. To come up with, I came up with some ideas then and some ideas since, and it's sort of been a passion of mine through my life, and researching this, understanding it better, trying to make some advancement in these ideas, more at a microeconomic level than your typical macro kind of theory. Game theory, my department focused on microeconomics, game theory, that sort of thing. So I loved it. It was a great department for me. Once down the road, around 2011, I was in New York City working on Wall Street, and I came across Bitcoin at that time in May of 2011. Yeah, May of 2011, and I was just sort of interested in exploring the ideas about how abstract money would work, or monies would work. And when Bitcoin hit my radar, I realized it sort of fit the criteria I was looking for. And so I became immediately interested in it, started participating in meetups. And there was a conference there that had 80 people. It was like the first worldwide Bitcoin conference in New York City. It was really kind of interesting. And then I moved back to San Francisco, which is my hometown, and attended meetups there. When I first got back in 2012, there was just one meetup in all the Bay Area that I knew of, which had maybe a dozen people. So things were really, not many people were really into it. And that changed like May 2013. There was a big conference in San Jose, and all of a sudden there were 80 people showing up, and then there were all sorts of meetups going on. And so, I was working hard at my job, and I was just trying to keep current with what's going on in Bitcoin at that time, and learning, about it through the meetups that I was participating in, the networking I was doing. And that just continued on. I got another job where I met you in 2015, where I came down in the South Bay. I live in Los Gatos now in California, which is about 50 miles south of San Francisco. I again was interested in doing some stuff. I wanted to do some open source stuff, but you're working so hard when you're working in a company, and I was just working all hours, as you know, and so 2018, I decided, okay, I'm going to take a break, and I'm going to try to learn on my own, and also start a project of my own and see how that goes. So anyway, I've taken the time off. I've been spending a lot of time learning. I also learned about short-term price movements. We've talked about that, you and me, Barry, before. I had a course with Tone Vays. I learned about short-term price movements because my training is more understanding long-term price issues. I mean, that's what my strength is. And then also I took a course from Jimmy Song to learn programming Bitcoin. He wrote a book on with O'Reilly on programming Bitcoin from scratch using Python, and I took that course. And out of that course, actually, and another activity I participated in Stanford, I went to Stanford Bitcoin Club and went through a Princeton book on Bitcoin and cryptocurrency technology. We did a peer-to-peer reading group, and that really struck me as a great way to learn. So, in fact, after the programming Bitcoin session with Jimmy Song, where he went through a bunch of stuff in 2 days, like a zillion miles per hour. What normally he would cover over a quarter, it's like sipping out of a fire hose. So a number of us decided to do it on our own. So we had a reading group that came out of that from the alumni, and we've gone through Mastering Bitcoin by Andreas Antonopoulos, another O'Reilly book. Andreas Antonopoulos led, by the way, the San Francisco Bitcoin Devs, which I participated in for years. And we've gone through programming Bitcoin, grokking Bitcoin. We're currently doing Lightning Network. There's another book, Mastering the Lightning Network, with 3 authors, including Andreas Antonopoulos, another guy, Rene Picard, and Roast Beef. We've also, in the reading group, done a number of other things with programming Rust, learning Rust, the Rust programming language. Both of those books. We're doing advanced Java. We've gone through Go and gRPC and some of that stuff. So anyway, the reading groups has been another activity of mine during my time off. And let's see. So that's just sort of a bit of background for me.
You mentioned in 2011, I think you mentioned about the Bitcoin exposure, right? And knowing yourself about Bitcoin a little bit. But I know you did a lot of work at Stanford about economic theory and currency movements and what have you. But what specifically about Bitcoin drew your attention? I mean, the fact that Bitcoin is, because at that point in time, I remember hearing about Bitcoin. It was a very esoteric term. And I think, I read a bit of white papers here and there, but I'm sure you dug deeper than I did. What specifically about Bitcoin gravitated towards you?
Well, okay, this is going to be a bit of a teaser, okay? Because actually I haven't put forth the ideas I've been working on. And everybody at Stanford, at Santa Cruz Bitcoin meetup gets all upset at me. They're like, you tease us too much. It's like, eventually, we'll have a second follow up on this. Okay, I promise. We'll do a little follow up at some point where I will go into those details. But right now, those things I really want to sort of get in some form, and I want to do an open source piece of writing where I bring out those ideas, and then I'll be able to talk in more detail with regard to what my thinking has been. For now, it's sort of something I've worked on hard, and I've just sort of kept to myself. But I will be sharing that. So in terms of the essentials of just to sort of talk about the questions, I won't sort of reveal the answers that I think I have. And again, I may be completely wrong, but the questions that I was looking at were really you can sum them up in two questions. And really questions are really most of the work that's involved. You ask the right questions. So, for me, the questions are, first, what makes for a good money? You have say you've come from a perspective of your traditional mainstream economics, where you learn Arrow de Brue, general equilibrium theory, and all this, and you've got goods and stuff and prices that happen, and it's really interesting to understand all that. It incorporates all the ideas from the marginal utility revolution of the late 1800s to understand price better, but still. Money isn't in there. It's just like you pick something. It's all relative prices. And so you pick something, and they typically use a fancy word, a French word, which is always, I'll mention probably another one by the end of this podcast. But they use the word numeraire to just say, okay, we choose one good, and that's sort of what we measure everything else by. It could be an orange. So, everything's in oranges, but, in the world, no, we don't use oranges for money. So what is it that makes for a good money? And so, and it could be that it's not just one money. It could be, that there are a number of monies that work together in some way. And so there's that question. That's one question. And then the second question is, what is its value going to be? And what are the values of the various monies going to be? And so that's another question. So these are the two questions that I've been focusing on. And I think they're, when I started thinking about this and working this, it was very, very taboo. I mean, this is like the dark ages back when I was at Scratch, and things have changed a great deal. When I was in New York City, I was talking with my old, one of my professors on my dissertation committee, who was working. He was saying it's just changed so much these days. Now it's there's seminars where people talk openly about free money, which is sort of the term that Hayek would use to characterize this idea of having various monies and seeing what works, sort of like free trade. You talk free money. It's not that the money is free. It's just that, there's freedom within choosing monies and what happens and sort of, how that all works. So I think times have changed. So now people are debating it, interested in it. So it's like heaven to me.
Yeah, I think, the fact that you had all of these ideas sort of percolating from graduate school and your sort of findings with Bitcoin, so just to sort of paint a very high level picture for everyone who have heard of Bitcoin, but don't necessarily know exactly what it is. And can you sort of explain what is Bitcoin from 1,000-foot level? And then we can sort of take it down from there. But I really want people to understand why Bitcoin is such the craze right now. And we can talk about other altcoins down later on, but just Bitcoin as sort of the OG, the main currency, the cryptocurrency that has sort of took off. What is that in a nutshell?
Okay, and just from 1,000 feet up, first of all, I am somebody who believes that, from my own thinking, that there will be one cryptocurrency that will dominate. Now, it could be that Bitcoin is superseded by something else in the future. And during the early years, I think there's a higher probability of that. As time goes on, I think there's a lower probability of that. So just from the onset, I'm someone who believes that there will be, one cryptocurrency that will dominate, and I see that as Bitcoin. And it's proven itself for quite a long time now, and so that's what I'm supporting. Although I am interested in looking at other things, like I was interested in Mimblewimble. We won't go into all that detail, but there are other cryptocurrencies that could supersede it and have better quality. So you always want to be aware of that. Bitcoin could go to zero. I want to tell everybody, Bitcoin could go to zero. So just always, if you're ever going to get involved, I tell my family and friends, just put in what if you're going to support it, just expect to lose it all. So right. just to start with. Okay. But that's not my belief. Okay. So with Bitcoin, we have something that is really, it's not a physical commodity. It's just ones and zeros. So how does that work? All sorts of people have qualms about that. They want to have something behind it, gold or something, and again, in gold, gold fits into my theories and stuff like that. There's reasons why gold was used as a money. But again, technology does change things as time goes on. And I think Bitcoin is something that is changing things as time goes on, but the qualities of a money, fairly classic. You can look back at history and sort of understand sort of what makes for a good money and think about it mathematically and figure out what makes for a good money. There are all sorts of different ways you can sort of get a perspective on this, but the point is that technology does move on, and there are these things that arise, just like Bitcoin has arisen, which maybe fit the bill. So Bitcoin, what Bitcoin is just to sort of give a very, very simple vision of it. It's an open source software. That means anyone can work on it and anyone can contribute to it. You can, if you don't like the way that it's going, you can modify it and have your own version of Bitcoin if you want. But basically, no one will follow you. You'll just be on your own. But there's sort of a mainstream Bitcoin, but it has forked at times. There was a big fork a couple of years ago, which got a lot. There's a lot of commotion about. But there's been sort of this main core, Bitcoin core, that has been the main line of this open source software. So all it is this open source software that's up in Git somewhere, right? So on GitHub, and so it's software. That's all it is. And what it allows for is peer-to-peer cooperation, where you're running this software on various machines, and somehow you are able to have this idea of something called the Bitcoin, and it's divisible into, it's not like you have to buy one Bitcoin. You can actually buy, what's called a Satoshi, I think, which is 10 to the minus eighth, if I've got that right, of a Bitcoin. It's, very small, and so, you have this ability to generate, and there's there's a cap to them. There's going to be only 21 million. There's sort of an asymptotic, as time goes on, there are more and more Bitcoins that are brought into the system, but it's an asymptotic thing. So it's scheduled not to go above 21 million total. Okay. So, that's sort of, at least for the layperson, that's really all you kind of need to know. For someone who's more technically inclined, there is this idea that, and this sort of ties in with something I was working on in 1997, 1999. I was working on a little project of my own to implement some payment for a timestamping service that somebody else had. And I sort of offered to try to help with that using my newfound Java skills and little Perl. And I think, timestamping then, really all it consisted of was this hash, which, whatever you're timestamping, you've got some text or something, a bunch of ones and zeros, whatever, a file, and you're creating a hash from it. Now, hash is a one-way function. It's easy to go one way, but it's hard to go the other. So when you generate a hash from a file, you're just sort of, in a way, characterizing that file. If someone sees the hash, you can say, this file, verify, this file goes with this hash. Now, if you put these hashes in a structure where they sort of build upon one another, and one hash will not only depend on the file, but also depend on the hash before it, you can have this chain of hashes, which is what the timestamping service was umpteen years ago. And you can periodically publish, say, in the New York Times or some, publication of record. This is sort of the thinking back then. I mean, now it's changed, but then the thinking was you periodically publish, and so you could have a timestamping service that would basically allow you to establish when documents existed. Say you wanted to prove that you had an idea at such and such a year, you could do it through this timestamping service. So that's sort of actually the root. A lot of sort of the root of Bitcoin is this timestamping service of all things, and so. Bitcoin kind of basically has this notion of having hashes and generating them and putting them into, and what they do is they sort of are trying to keep track of transactions. So when you move Bitcoin from person A to person B, that's sort of what you're going to be, in a sense, hashing is that record of you're moving the Bitcoin from one person to the other. And so they have a structure which is a little more complex than just a simple sort of line of hashes that I was just describing. What they do is they bunch them into these blocks, and so you have a block of these transactions, and there's a limitation to the size of the block. And on the average, every 10 minutes, people who are working on verifying these blocks to make sure they're actually valid, there's no double spending, things like this. There are people who are working on that, and they solve this little mathematical problem that takes computing CPU computing time. And so it's not cheap. And whoever comes up with the answer first gets to be the one defining the next block. And so every 10 minutes, a new block is put on average. A new block is put along, on this blockchain now, rather than a hash chain. It's a blockchain. And there's some, details with regard to all that when, I won't go into now. But basically, that's the idea, is that there's some way to make sure that we have sort of solidified in like those mosquitoes in amber, they find you you want to somehow have those transactions in amber and stuck there so you can see them and make sure, they're there, and you just sort of have this record, almost like a geological record of all these transactions that are accumulating, and you can say, okay, yes, this transaction happened back, 5 years ago, and you can sort of track all these Bitcoins the way they're moving around, and it's a little more sophisticated, which is kind of neat. Bitcoin can not only move money from person A to person B, but you can have, like, for example, these transactions where the Bitcoin will move into a state from which you need the okay of 2 of 3 people to move it to the next state. And so you can imagine all sorts of interesting things you can do with escrow and things like this. So there's a scripting language within Bitcoin, which is very simple because you don't want to have any. You want to keep your vulnerability, your security, your vulnerability, cross-sector, whatever, kind of limited. So it's a very simple scripting language, but it does have some power.
Yeah, I think that was a really cool explanation. I think that sort of explains a lot about sort of the intricacies of Bitcoin. I know that it can go significantly much deeper than that, and we can sort of talk about.
You can join my reading group to do that.
Yeah, we can talk about your reading group later on. But I think for the most part, we know the crypto world and Bitcoin specifically really launched a new industry for not just cryptography, but currency, supply and demand, economics, right?
Yeah, I mean, there are all sorts of levels to it. Just to sort of bite into what you just were saying, which I think is what you're trying to get.
Right.
Okay, there are a couple of things that are really outstanding for me. One is just the principle of having good money. I think a good money in and of itself will allow for a much healthier economy overall, and that's one topic just of it in and of itself. Secondly, what's really exciting to anyone who's a software engineer is when you have it's one thing when you have software that's sort of working with itself. I mean, sort of software that's designed by one company that does sorts of things with one company, and that's great, fine. However, what if you have software agents that are from different companies that are sort of strangers to one another and don't necessarily trust one another, and they are dealing with issues of cooperation and scarcity? Well, having some way of for these software agents to exchange value in some way, just on the fly. I mean, imagine you're trying to do a set up some sort of system outside of the internet where you're trying to communicate and use bandwidth on the fly, and you want to be able to pay for that bandwidth as you need it from the next cell phone or something that you just are creating this mesh network or something, or whatever it is. You just, as sort of an example, this offers an opportunity to be able to do that sort of thing.
Yeah, no, I think, I guess that sort of leads on to my next question about all these applications, right? So Bitcoin is just one application that we've spoken about on this blockchain that you mentioned, right? So you had the hash chain and then sort of manifested into the blockchain. And, there are many types of blockchains, right? So with the Bitcoin blockchain, right, can you talk about the decentralization of that blockchain, right? You mentioned about this ledger, or sort of all of these transactions between you and myself, between you and your friends, your family. How does that get stored?
Everywhere, which is one reason actually, and maybe eventually we'll talk about Lightning Network. I mean, there's an expense to this. And talking about scarcity, there is a scarcity of a resource, and that resource is each of these blocks. These blocks are limited size, and so we just, the sky is not the limit. And as Bitcoin has grown, it's reached that limit of the block size. And now there's a big discussion about that and whether to increase the block size or not. And that's actually where that fork came a couple of years ago. So that's another whole story. But the point is that as Bitcoin as it is, and as I expect it to continue to be, has this limitation in the size of the Bitcoin block size, which means that there's a scarcity. And so it's that scarcity, that expense, is because really everyone who's running a node, and maybe mining and all this sort of thing, participating in the system, they have to be able to have these copies of all the blocks, that they're working with, and so there's an expense to that. And if we do talk about layer 2 sorts of technologies, where you build upon the Bitcoin core technology to add sort of features and an extra layer on top to facilitate faster and cheaper and smaller transactions. That's something called Lightning Network. That's one approach that's being taken and explored, and that's to sort of deal with this real expense that is involved with those blocks being replicated everywhere.
So if I'm a node, right, and you mentioned like anyone can be a node.
Mm-hmm.
So how would someone go about setting themselves up as a node in the blockchain, in the Bitcoin network?
Okay, so all you have to do is install a Bitcoin Core node, and for example, in our Lightning Network reading group, we've just gone through a couple of sessions where everyone was installing their Bitcoin Core node and also a Lightning node, and again that's something separate, but it's just a matter of following the directions, and
so literally, it's all about going to a website or downloading the core, the open source software, installing it onto your machine, and then away you go, right?
Yeah, away you go, and you've got it. I mean, the wallet that's included is sort of a, is not the wallet you want to use. We can get into that. But the core functionality is the defining core Bitcoin Core technology. There are other implementations of it. But there is one Bitcoin Core, which is the dominant one. There are other implementations in Go and Scala and different languages. But if I were just sort of playing with this, I just install the Bitcoin Core somewhere. I mean, I've installed it on a Raspberry Pi. It's
so what is it? What is it actually doing? So once you install it and you let it run,
mm-hmm.
and let's say I'm just on a MacBook at the moment, for example, what is the software actually doing on the computer?
Okay, so let's see. So you didn't want to get too technical, or do you want to get technical
well,
now?
We can get a bit technical here.
Okay, so first of all, I did mention mining, which is something that the big boys do now. I mean, and girls, this is something that initially, when you download the Bitcoin Core and all that, I mean, from way long ago and far away, people would run this on their own machines, and they'd be mining and stuff like that. But it's right now, it's really something, the margins and all that. I mean, it's something you do really only as a professional. And so when you download the current Bitcoin Core software, you won't have the mining software abilities. So that's just to start with. You won't be doing the mining. That's that's somewhere else where you need to kind of talk to the that's serious business, and there are all sorts of different special processors people use now, and all sorts of things like that. So. But with the Bitcoin Core node that you would run yourself, you're going to be, your software will be communicating with other peers, setting up sort of a network with other peers, and exchanging information about the blocks. And in fact, the initial process is that you'll get a bunch of headers, and then eventually all the block information will be downloaded, and that can take some time. Now, I think last I did it, let's see. It can take a couple days, just the initial, but it's a lot faster now than it was a number of versions ago. Where almost, I think it was like taking a week or something. It takes it used to take a significant amount of time to get all those blocks on your machine, so you can sort of, be up to speed with the whole blockchain and be able to verify the next block, in the chain. So really, that's your software will be downloading all that information, and will then be in a position to make sure, be able to verify any new blocks that people, other peers are communicating information about. And with your wallet, you'll basically be able to participate by sending and receiving Bitcoin. So there's a GUI that will appear. And again, this software. They're much better wallets than the Bitcoin Core wallet. The Bitcoin Core does the core stuff well, but the wallet is sort of pretty basic. So I would recommend other wallets instead of this one. But it does have a wallet where you can send and receive Bitcoin. Let's see, I hopefully, and within this discussion, I can mention hardware wallets as probably the best thing for people to use.
Yeah. Let's quickly talk about the wallet stuff, because, I know that, we've established at least the baseline here where, anyone can be a node. You can contribute to the network.
Mm-hmm.
You can send and receive Bitcoin currency. You just need to establish effectively a software or a hardware wallet. Now, I know a lot of people out there have been hearing things like Coinbase, and they've been hearing other sort of companies sort of coming to the fro here, and sort of really establishing themselves as current players in the cryptocurrency markets, right? So, for people like Coinbase, right, would you say that is is that a wallet?
Okay, so Coinbase is a great way for people to sort of get involved to start with. And for others, to continue with in some aspects, but it's a very simple service to start with. And I still remember when Brian Armstrong, who heads Coinbase, was just another guy at the San Francisco Bitcoin Dev meetup. He started this company, and here he is doing so well in San Francisco. And so what it allows for is that you can basically connect your bank account to their service, which will they have an exchange as well. So they can take your money from your bank account and exchange it for Bitcoin, and you can keep it there if you want. If you don't really know what you're doing, maybe that's fine to start with. However, there's a very important point with Bitcoin, and that is there are keys that you have, and that's really what a wallet is. It just holds on to these keys. And the keys that you have are really what control the Bitcoin ultimately. So, it's better really if you have your keys yourself, and that way you're controlling the Bitcoin yourself. However, when you use a service like Coinbase, they have the keys. And so you're really trusting them to behave. And so, it's an easy service to use, and it's nice for people who really don't want the complexity and you have to sort of know what you're doing with these keys. If you lose them, then you've lost your money. So, as you learn, maybe you'll start playing around a little bit with what are called hardware wallets, where the keys are on the hardware wallet. And we can talk about that in more detail if you'd like. But that's sort of the next step, I think, up from Coinbase. So
what is a hardware wallet then? Because we know, at least we've established that people like Coinbase will take the dirty work and really do everything for you, sort of abstract that layer and sort of really just handle all the busy stuff. But I really, the hardware wallet is also a bit interesting because effectively you can take your money, which effectively are a manifestation of your keys, and you can go ahead and you can, take that wherever you go, and that is your bank account effectively on the hardware wallet. So just give us an example of why hardware wallets are so valuable and why they're so important as opposed to a software wallet.
Okay, so first of all, when if you do start to get involved with Bitcoin, it's very important to know a bit about just sort of the basics about security. I mean, sure, you can have there are apps you can have on your smartphone, and you can pay with Bitcoin through these apps and stuff. That's fine. It's just don't treat it like a wallet that might be taken. I mean, just don't have that much money in it. And so the security on a smartphone is not great. So just assume that, it's going to be vulnerable. So you have a small amount there. Then I think the next larger amount, perhaps, you have something in Coinbase, or preferably you have your hardware wallet. This is a hardware wallet, example of a hardware wallet, where you hold your Bitcoin and control the key there. And then there's a next level. If you have a lot of money and all that, there are all sorts of strategies with regard to making sure that everything is in a safety deposit box, or you've got multiple information, multiple keys that maybe you have and your relatives have, or your lawyer has, or there are all sorts of different strategies there. So there are all these different kinds of levels of strategy depending upon the amount of Bitcoin that you would have. So these hardware wallets are sort of the middling level of security, and so what they do is they allow for the keys to be on the hardware wallet and not on the computer. So you can have a situation where on the computer you're communicating to the internet and all that sort of stuff, but no matter what sort of terrible things are happening on the computer, it won't be able to access your keys here. You can connect to the computer and you can do things. Basically what happens is there's a transaction. We've talked about transactions. So a transaction will be created, will be created, and this hardware wallet basically has the keys with which it can sign such a transaction, and then the signed transaction can be used. And without basically holding holding the private key here in the hardware wallet. So that's sort of the basic idea, is that you can have the transaction coming in and the signed transaction coming out. That's fine. And so then use your computer to distribute them, publish them, or whatever. But basically, the keys stay on the hardware wallet.
So effectively, you are the full possessor of those keys, no matter where you are. You're not relying on a third-party service to host the keys for you, or even generate the keys on your behalf.
Right. The risk is you. If you somehow aren't maintaining, the information you need to regenerate, the information, get access to this. There's a passcode involved here, and PIN. And there's also a number of words when you set these things up, which you can put in your safe deposit box, a list of 12 or 20, depends, where basically you can regenerate all the private and public keys from that list of words. And, if you for some reason don't put in your safety box and it burns up somewhere and you just, don't have access to those words anymore and you forget your PIN, it's your dead meat. So there's a risk with regard to having control, but then again, if you yield that control to Coinbase, there's a risk there as well. Now, Coinbase also has a service called the Vault, and again, for people who really don't want to bother with all this, there's some service where they're trying to really be super protective of high amounts of Bitcoin too. So, it's just. It's if you don't know that much, I'd use a service. If you want to learn more, eventually I'd encourage that so you get more control. But maybe play a little around before you really put a lot in here, because you may make some mistakes initially. So,
what's the name of that hardware wallet?
Oh, this is a Trezor.
Trezor. I'll put the link into the show notes at the bottom.
There are a number of them. Trezor, Ledger. There's another one too that's.
Yeah, I think it'll be cool for people to take a look at what they can offer.
Here's another one, KeepKey, that was given to me at a conference. I still haven't opened it. But...
Oh, that's a big one.
Well, it's not. I mean, it's just the box.
Just the box.
I'll just open it now. But
no, I think that's very cool. And one of the things that I wanted to also talk about with regards to not just the decentralization aspect of it, but also the anonymity, right?
Mm-hmm.
So why don't you explain to us a little bit about your identification when it comes to becoming a participant? Oh, there you go.
Here's what was inside the box. So it's okay.
Okay. I'll get the links from you after the show so we can put them in the description. But I want to understand a little bit about the anonymous aspect of it, right?
Okay.
Because when you participate on the network, you don't have to reveal who you are.
Yeah, it's what you call pseudonymous, which means that there are public keys that sort of represent who you are, addresses, and this is when you move Bitcoin from one place to the next, from one person to the next. really what you're doing is you're moving it from one address to another address. Or again, you could be in a state where maybe multiple people need to release it. I was talking about all the complex sorts of things, 2 of 3, and all sorts of different things that the scripting language can allow you to do. But let's just take the simple case where you're moving Bitcoin from person A to person B, just the simplest transaction. Well, this is done between addresses. And so that address is a public key. Now, one thing that's very interesting is that Bitcoin has this really interesting approach where it uses what's called a hierarchical deterministic wallet, which means that from an initial set of words, I mentioned these words, that you could regenerate all your keys from. Well, there are these words that and again, you note them down and you put them in your safe deposit box. These words basically are seeds for the generation, sort of your initial entropy, to generate these keys in a deterministic fashion. So, in fact, you aren't really rolling dice or anything. It's like, you're rolling dice to generate those initial words. That's the initial sort of randomness. And from that, you are generating a number of keys in this hierarchical fashion. So there's this way of generating a multitude of these keys, and they can be sort of related in their various silos, which is sort of interesting too. So there's all sorts of interesting features where you have a company where some people sort of have control of these keys and these keys. And I mean, there are some interesting things, but just basically the point is for an individual is that you have this ability to generate a number of these public addresses, so you aren't using the same address each time. If you were using the same address each time, then a pattern could be identified just by going through the blockchain and identifying sort of, okay, there's this money coming in, there's this money going out, at that one address that doesn't have your name on it, but it's just, the point is, well, if you figure out maybe one transaction that does involve you, well, you can sort of figure out a bunch of things. So people generally will try to protect their privacy. Say you just don't want people to know your salary. I mean, if you're being paid by a company, you just don't want people to know your salary. I mean, basic privacy. So, the point is to have a multitude of these addresses so that, and that's what a hierarchical deterministic wallet will give you, is this ability to generate multiple addresses, and that people can't really tell. They can't really, if they do it right, there are some, stipulations in which these you use, but if you do it right, these addresses aren't addresses that can be related to one another.
Got it. That makes sense. Okay, so I feel like there's this tree that's being generated, and from that tree, there's this, the seed that you mentioned is something to sort of kick off that process. And once that process is kicked off, then that can be associated with a particular transaction and the particular identity, and a lot of back and forth happens between that process, right?
Yes.
And that sort of gets imprinted onto the ledger.
And what's sort of interesting, just as an aside, is that, the pseudonymous is sort of cool because, in fact, if you think about it, you can have a situation where, say government starts using it, and here you are with tax money, you contribute, and you want to make sure there's no corruption, and you want to make sure that the money that you have gained in taxation is going to the right people, that they're really using it to, build roads or whatever it is. What's interesting is you could imagine that governments could be very transparent by identifying the particular wallets or the addresses that they're using, and just stick with those addresses. And then citizens can be, sort of the openness that allows for citizens to really check to make sure there's no funky stuff going on.
Do you think that could also be applied to the election?
Oh, too dangerous to touch. Too dangerous to touch.
I think you mentioned government.
Here's the Chinese address here. And I'm not going to. Communist. I should say rather than Chinese. The CCCP, Chinese Communist Party. Be specific.
Right.
Just not to get in any trouble here, but just as an example.
No, I think you just mentioned the government, and definitely, we always hear about malplay and all of those things. So definitely having some elements of the blockchain be used to verify transactions. Oh, I am the one who voted. This is me. This is my identity, right? I think that can have huge impacts.
Oh, with regard to voting and stuff, there are all sorts of there are people who are trying to sort of incorporate. Either through a separate cryptocurrency or, I think My personal opinion is that a lot of there's a lot of interesting technology that can be sort of anchored into the Bitcoin core for security purposes. I think, military sort of things. I mean, all sorts of things can be can start using the Bitcoin blockchain for various things. I mean, IoT, there are ways of, like in Grokking Bitcoin, there's a nice little section where it talks about how you can, I mean, one issue actually this came up in our last company, where we work together, where, you basically have a situation where, you have a certificate that you're saying represents you, and when you're communicating with your internet, your IoT device, and what if you want to change that? Something's come up, and you want to alert the IoT devices to the new state. You could do the revocation, but there's also, I mean, it's sort of a bit of a, I don't know, it's just not completely satisfactory to my mind. And there are ways of doing it with sort of communicating through the blockchain, where you could alert the IoT device as to that change of state. And so it would know to not trust the old certificate, but trust the new certificate. So I think there are a lot of interesting sort of applications, and with voting too. Perhaps there are ways of using the blockchain, anchoring in what you're doing with the blockchain to enable some really unanticipated things.
Yeah, no, I think the breadth of crypto not just applies to currency. I think once people start to get into, I think what they'll probably do, and this is how it worked for me when I started to learn a bit more about the crypto industry and in this space in general, is you sort of look at Bitcoin and you sort of understand, okay, everyone knows about Bitcoin and that's sort of your entry point. But then you start to realize, oh, wait a second. I mean, Bitcoin is just one application of crypto on the blockchain. You can have so many things using this, everything from, as you said, voting to supply chain management, IoT, other fancy security mechanisms that you can use because at the end of the day, it's a ledger, right? And the ledger is used for record keeping purposes, checks and balances. And it's all about how do we maintain those ledgers as accurate and as verifiable as possible, right? And this sort of brings me to my next question, which is about the verifiability of these transactions, right? And I'm sure people have heard things about proof of stake and consensus and what have you. Can you just provide, I know, and things can get a bit hairy when you sort of go into these sort of topics, but just provide a little bit of an explanation about what does it mean to have a transaction verified and what certain techniques can you use to verify these transactions?
Okay, and my biases will show in this because again, I'm very Bitcoin focused, which is Bitcoin uses proof of work, and so in a lot of ways, I'm sort of la with regard to a lot of the other cryptocurrency efforts because I just from the outset I just don't think that they're that interesting. Most of them, I mean, some of them I do pay attention to, but so I don't really delve into so much of that knowledge because actually I just don't think it's gonna fly. So, but I will explain the Bitcoin part, and also I just want to touch up on one thing you said in the last thing with regard to supply chain. I think there's one person I knew from the San Francisco Bitcoin Dev who helped found something called SKU Chain, SKU Chain. Chain, and I believe that's the name of the company, and they were trying to do that very thing, sort of follow the. I mean, that's a very interesting thing, to be able to track a product from where it's made to where it's sold, and make sure, like with pharmaceuticals or something like this, it's very important to kind of make sure that, there's not any funny business going on in between. So, and also, I mean, it's sort of interesting because in terms of ethical payment or ethical purchases, like say you just want to give a tip to somebody who made this dress that you bought for your wife, and she's in the middle of India somewhere, and you just say, well, she did such a great job here. I want to know who she is, or somehow be able to give her a tip instead of all these middlemen, And so I think it'll be really interesting to see how that affects sort of also making sure that what you are buying is ethically created, not by any sort of form of slave labor, for example, or debt peonage, that sort of thing. So anyway, I'm sort of excited about the kinds of things that will offer, sort of another tangent we won't go down, but I just want to mention that. Back to proof of work. With regard to verifying a block on a blockchain, Bitcoin uses something called proof of work. Now, other cryptocurrencies will use something else, proof of stake, where it depends on how many of the coin you have, and it gives you a certain weighting with regard to how you participate in the verification each time, and you can delegate. Some of them have delegation models where you can delegate that, so you don't have to do it yourself all the time, but you delegate to somebody else to do it. My knowledge is a bit sketchy on those things again, because I just don't. I'm just not so interested in that. But proof of work with regard to Bitcoin is sort of really, what Bitcoin is a bunch of different technologies that kind of came together and somehow fit together and worked. And proof of work was a very important element of this. I mean, because, how do you verify? And now, as I said before, there are computers that are running these simple programs to compete in order to solve a problem. Now, this problem is a very simple problem. It's just taking some information and changing a few of the bits here, and then generating a hash. So each time you generate a hash, you check to see like how many zeros there are at the end. Okay, randomly speaking, it could be a 0 or 1, so you have a half chance of a 0 1 at the end. But what chance do you have of a 0 0? Well, that's 1/4. 0 0 0, that's 1/8. And so you can see that if you really wanted to have something that was 1 in a million, you'd figure out how many zeros you need, and then you'd say, okay, everyone, start running your engines, and let's see who gets the first hash that has so many zeros, and then you win. So it takes some time, because there, a million people, you need to try a million times, on average, to get this. And so now what happens is, as more and more people get involved, it happens faster and faster. Well, you still want to keep it every 10 minutes. So what you do is you make it more and more difficult. So you add more and more zeros to the problem. So it gets to the point now where, the amount of power there, it's really able to withstand. My understanding is sort of at the level now where really the security can withstand state actor level attacks.
Wow, that's really cool, because I feel like you're increasing the complexity upon each iteration, because you said you're adding zeros and you're making it probabilistically that's much more harder to break effectively.
Mm-hmm.
Right.
And so what's happened too is there's the sophistication, and this is why it's so professional, is that, initially you just had your normal CPU type of computer, then people started using GPUs, and that's faster. And then ASICs. I actually knew a guy in New York City. We were like two of us in this one meetup. Sometimes there were three of us. Again, very few people involved. He was the first one to come out with an ASIC, the Avalon. And he was a big star at the May 2013 conference. And I knew him when he was just nobody.
Wow.
So the ASICs are where this hardware is sort of geared to specifically do that particular software application. It's more
of a hardware implementation of whatever you're trying to do, right?
Exactly.
Yeah. I think the verifiability is still there's so many methods around it, and I know that there are different blockchains like Ethereum and esoteric ones that are trying to somehow scale the verifiability aspect of it, because it does take time, it does take resources and all those things, right? And so the question is, how much resources do we actually need? Because in order to verify a transaction, personally, I don't think my laptop will be able to handle it. It's really about having those Bitcoin miners out there to really do all of the heavy lifting, right? So go ahead.
Well, you can verify it. It's just a matter of whether you can be the verifier of record. You can verify it. Everyone can verify it. It's over, plain view, and everyone has the power to be able to verify all the transactions, make sure they're upright citizens of the Bitcoin transaction community. But the mining is really now there are certain efforts with regard to, like, one thing that I hear you saying a little bit is, oh my God, there are all these resources put into this mining. And so some people talk about that. Well, the thing is that people have to realize is that it's very important to have a good money. And when you don't have a good money, you're going to be wasting a lot of resources from not having a good money. And also the monies that preceded, the good monies preceding Bitcoin were like gold and stuff, where maybe you're doing all sorts of terrible things to the landscape. And so there's going to be resources that are behind the power of this money, but then you also have to think about it's not just sort of a good money really has these benefits with regard to making sure the economy goes well and that the resources aren't wasted out there. And so people should be cognizant of that aspect of it. And moreover, I think Andreas Antonopoulos had an interesting video where he talked about how it actually helps with regard. There's a video where he talks about energy being used in remote locations for powering Bitcoin, and the fact that you can do that at a remote location means that you don't have to you don't have to move the energy. You just move the Bitcoin, and there's sort of an efficiency with regard to actually getting something. I can't remember exactly, but I shouldn't talk about it because I don't remember it exactly. But he also talked about sort of the ability to sort of ramp up these energy plants in a way where, or be able to smooth out their like if they have demand that sort of wavers and you want to smooth it out. Bitcoin, using the excess power to generate Bitcoin sort of allows you to do things with energy plants that you might not have been able to do before in a more environmentally friendly way. I don't know. I don't know enough about that to tell you anymore. But I would recommend Andreas Antonopoulos' video on that.
Yeah, it's an interesting topic to. I think in and of itself, it's an interesting topic because there's so many I don't know initiatives out there to really figure out a very efficient way of doing these sort of mining operations. And I know in China, I think there was a documentary on mining farms in warehouses where they're effectively setting up machine by machine by machine, just a whole stack of them lined next to each other to really harvest Bitcoin, right? So that's been an interesting development that's been happening in parts of these parts of the world. So, with that, I want to understand a little bit about Bitcoin obviously is the first currency that sort of really became popular, but recently there's been a lot of forking, I suppose, or just, I guess, maybe before we get into other alternatives of Bitcoin, when someone says Bitcoin got forked, right, what does that actually mean?
Okay, so in the open source software world, what that means is that there are various projects that are very there's so many open source projects that people are working on that are done in a way where basically everyone can can contribute as peers. There generally is somebody who is responsible for starting the project and may lead the project. Like Linus Torvalds leads the project on Linux, which is an open source project that's very famous. But there's he also has created the Git software that everyone uses for source control. That's another open source project. There are some open source projects that weren't created by Linus Torvalds. There are just countless number of projects, open source projects, and what you generally have somebody like Linus Torvalds who will sort of guide the project and sort of control the changes that are happening. And the rest. It may be a number of people who are involved, sort of to maintain the project. It really depends a lot on your contributions and the respect you gain from those contributions. The quality of those contributions and all that. And with Bitcoin, for example, there was an initial creator who is no one knows who that person was. He transferred his leadership to Gavin Andresen, and then ultimately there have been a number of other core developers who've taken over that leadership now. So it could be that there's a disagreement that happens, and so when there's a disagreement, and this is what happened several years ago with regard to that block size that I was talking about. Some people wanted to increase the block size, some people wanted to keep it, keep it pretty much the same or not too much bigger, and then have fees that would be have a market mechanism because there's some scarcity in the block. Part of the mining process would be that the transactions would also pay fees that would match sort of how what the price is to get into the block, and as it gets more, there's more and more demand to get in the block. Of course, these fees will go up, and in fact, that's an additional way that the miners are rewarded. And in addition to the bitcoins that are sort of gradually added to the system, as I said, asymptotically, there are also these fees. Okay, so anyway, there was this big debate about the blockchain size, and so some people went this way, some people went that way. They took the code and they started working on it separately. So changes over here were different from changes over here. So you have these two distinct code repositories where the code is, and people will run this software or they'll run this software. And so you have a system where basically there are going to be these two different versions of Bitcoin that are out there in the world, and they may have a shared history. But once that fork happens, they will be distinct.
So how does one decide which fork to go with? I mean, is it based on the principles that you've adhered to, that you believe that, this new fork that has just occurred is something that I'm more aligned with, and therefore I'm going to continue trading? But at the same time, I feel like you still need a community behind it, because you can easily fork Bitcoin, but if you don't have the support behind you, then you don't really have a good basis to really spawn a new a divergence from that main line. So I'm just trying to understand what has been the history like for Bitcoin specifically, with all of these forks that have taken place. Have they been legitimate enough for people to have a mass following behind these forks?
Okay, so yeah, I still remember way back when. Again, it seems like decades ago, but it was just 9 years ago, 2011. You started hearing, well, probably 2012 when I heard about this, but it's like there was somebody who set up a website where you could actually just do a one-click fork of Bitcoin, and you could name it Berrycoin, Casey Coin, and you'd have your own coin. It was just, hey, we've, just that easy to fork, right? So, but then, you're just trying to convince your friends, hey, let's use Berrycoin. Well, okay.
Right.
It's hard to get any kind of momentum going. So yeah, that's a problem. So now the fork that happened several years ago was much more serious, because there were, groups on either side that people knew. And of course, I can only tell sort of, I can talk about sort of what went into my thinking, and what went into my thinking was, who are the people, do I trust technically the people that are involved with the fork on this one side or the other side? I do in terms of software, in terms of just your basic coding and cryptography, and just general knowledge about all the bells and whistles that go into Bitcoin. That's number one. Number two is thinking about it economically. I mean, I think there were certain different theories about what makes for good money, which I have my own ideas about, and so that will factor into the kind of decision I make. And I think that the other fork was misguided in its understanding of what makes for good money. So, that's my personal opinion. I may be wrong, but again, that's how it went into what went into my choice. And then there's also sort of the ineffable sort of the character of the people involved. I mean, there are character questions as well. So there are all sorts of different levels to it.
Right. Okay. Yeah, I feel like there is a lot of debate, and I think it's a healthy debate to really think about the future of not just Bitcoin, but all of these manifestations on the blockchain, because it is software, right? And software can change dramatically, and it can change very easily as well. But at the same time, there's always a community behind these implementations, like, as you mentioned, Linux, right? And people have their own beliefs about where the roadmap is for Linux and where it should go. And others are either opposed to that or they're aligned with it, right? And I feel like it's always good to have a healthy discussion about the roadmap of these currencies, right?
Yes.
And so from your personal opinion, do you see where do you see Bitcoin going in the next few years? Right? Do you feel like where it's headed now is correct, or do you see there's need for change?
Oh, I'm very happy with where Bitcoin is now, and again, I think there's a lot of exciting work that I think is being done in this layer two. I was talking about Lightning Network is being.
Yeah, go ahead. Why don't you explain a little bit about what Lightning Network is?
Okay, I will. It's think of Bitcoin as sort of this sort of I don't know. You can think of it as sort of this core sphere of Bitcoinness that is just sort of there. And okay, we've talked about that. You just assume it exists, and then we have this second layer that's sort of this shell around Bitcoin that is doing some other stuff that's that's based on the Bitcoin core technology. And why would you do that? Now, there are other things that you might do. Again, we've talked about other sorts of different interesting things you could do by tapping into the Bitcoin core or the blockchain, just using it as a timestamping service, for example. You do all sorts of different things as a layer two. Now, what Lightning Network does and what it's trying to address is the very expense that we're talking about. When you have a block where you're charging fees for these transactions, part of the whole fascination with Bitcoin was sort of this idea that maybe, when I started getting interested, when I did this project back in 97, 99, I was working with something called DigiCash, implementing with DigiCash, David Chaum's technology with regard to micropayments at the time, because we didn't think at that time that credit cards would be something that people use online readily, security reasons. But that was a mistake. But David Chaum had this idea with DigiCash, and there were other efforts. I remember First Virtual, Millicent, these sorts of things, and there were ways of sort of trying to make for small payments online. And the problem with credit cards is, of course, you've got for each transaction, you may have 40 cents as a charge in addition to, whatever. There's this, you can't really charge just 5 cents because the transaction cost is greater than the amount that you're charging. So it really is hard to have these small payments. Now, again, with Bitcoin, that was the case initially, that we would have these very small, it'd be very cheap to send, to have these transactions because there wasn't this fee. It was negligible, but now it's not so negligible, and it's getting more and more expensive as time goes on. So, what do you do to pay for the cup of coffee without having to spend, an inordinate amount in your transaction cost? So, and moreover, how do you make them more instantaneous? Because with Bitcoin, there is this 10 minute average wait between the blocks being created, and each time those blocks are created, that's sort of added verification. But most times people will, for various reasons, want multiple confirmations, maybe 2 confirmations, or in a case of a very serious, large purchase, 6 confirmations or more. If you're, buying a house or a car, you probably want to wait a few more, maybe even. So that takes time, it's an hour or something, right? And here you are waiting for your cup of coffee. Okay, so Lightning Network is a way to address that. It's meant to be fast. It's meant to be cheap with regard to the transaction fees. There's something different that happens. We'll talk about, and so and small. You want it to be able to deal with these really small payments. So. What it is a way, you can think of it as a way, what happens is basically you have a funding transaction to start with between 2 people, which is sort of like what I was saying, 2 of 3, but it's 2 of 2. So you move the money into a state where only both people have to okay the money being moved out of the state. And that's called a channel. And so you fund it with a certain amount of Bitcoin, 2 people, and then at the end, you close out this channel, and you need the cooperation of 2 people to do that. Now, there's a transaction that goes into blockchain for the first initial funding transaction. There's a transaction that goes in for the closing transaction. However, what's really interesting is that this is kind of like a bar tab. So, if you're going to a bar, maybe, you go there, you don't pay with your credit card each time. Maybe the person there knows you enough that they say, oh, well, you can put it on the tab, and the guy will do, the bartender will do that, and you pay at the end. And so rather than paying, twice or 3 times or whatever, you pay just once. And, there are other, I think online I've seen other efforts at like trying to do credit transaction consolidation to save money. There are approaches that just basically try to do that, to save on the transaction costs with credit cards. Now with Bitcoin, it's the same sort of idea. If you have one funding transaction and then one closing transaction, and you can somehow do transactions in between, moving the money back and forth in this channel. So maybe each person contributes one Bitcoin. And so the channel has two Bitcoins inside of it. And you can start saying, okay, I'm going to pay you a tenth of a Bitcoin for this service. And I'm going to pay you a 2/10 for this. And then, I'm going to pay you, half a Bitcoin for what you just did for me. And so you can imagine between these two people, you have this relationship and you have this channel whereby you can move the money and somehow not have to have a real full transaction in Bitcoin that costs money, because the funding transaction at the beginning and the closing transaction costs money. Right. So what is done is that you create these sort of transactions that are signed, and each person has control of, in such a way that there's a bit of game theory that happens. So there are incentives that are put in place so that, as you're creating these transactions, moving money back and forth between the two people in this channel, there's an agreement with regard to how you get from state A to state at time t equals 1 to state time equals 2 to time equals 3, where the Bitcoin is moving here and there, and there are these new transactions that are being revealed and shared and held, and incentives to not use the old transactions. So it's only the new transactions that can be used, but they aren't used in the happy path. They're never used. It's just you sort of are giving this structure so that there's this game theory that happens. So at the very end, when you have the closing transaction, you have the incentive to actually have a closing transaction that matches all the transactions that you've had in between time.
Right. Okay.
So it's really fun. I mean, the details are really fun to go through, because you're using the scripting language, and there are time delays, and there's punishment if you do it the wrong. If you try to rip off the other person, and they can actually get all your money. It's like there are all these incentives with regard to if people don't play by the rules. But if you play by the rules, you have the opening transaction, you have the transactions that move back and forth, and within the capacity, the two Bitcoin capacity of this channel, and then a closing transaction. And what once you can do that, you can then set up this network of these channels so that you can have not just two people, but you have this network of these two people, and then this person is connected to this other person, so they got a channel, and then you got the whole network of channels, and you're using Tor network, and you're doing all sorts of interesting things, and eventually you can connect to the guy who has the coffee shop. And so at the end of the day, basically, you can pay for your coffee, and you can get your coffee without having to wait for an hour. And maybe play, I've actually, when I first installed the Lightning Network, I was able to play this little game of Space Invaders for like 5 cents. It's like, wow. Or maybe it was even half a cent. It was just like, it's a really small payment. So I think it offers a lot of interest there as well. The fact that it's fast, blah, blah, blah. So,
I think that's really fascinating, because, I know that there are significant transaction costs associated with just, if you just remove the Lightning Network away from it. I mean, just to buy, as you said, buy a cup of coffee, go to the store, right? These are very simple transactions that we take for granted every day. We use our credit card, but there's a lot of intricacies and complexities behind using Bitcoin. And I think the Lightning Network has this ability to really democratize Bitcoin for everyone now, so that everyone can access this, right? And I want to sort of dig deeper in a little bit about how these transactions, not dig deeper, but, if I was someone who had a Bitcoin wallet, for example, and I have money stored on that, how would I convert that Bitcoin, whatever I have, into a transaction that is associated with a purchase? So I go into a coffee shop. How do I use the Bitcoin that I have to really buy that cup of coffee? Now, does it get converted into USD or the currency of that coffee shop wherever it's located, and then sort of there's like a multiple transactional process that takes place, or is it Bitcoin to Bitcoin?
Okay, so let me start by just saying one thing, and that is just the obvious, that Bitcoin is very volatile right now. The price it started from nothing, right? And it's going to some place. And that there's the second French word, which I was dying to use, called from my economics trading, the word tâtonnement. And it's just, again, a fancy French word, but all it means is fumbling around for price. So eventually, there's this process that takes place whereby we move from point A to point B. And eventually, I believe that the price of Bitcoin, volatile as it is now, will eventually be very boring. And so at that point, I think there'll be less of a need to, right now, when people hold on to Bitcoin, say, they really don't, they're just sort of, they just are trying to use it. There's a bit of a dissuasion because, it's just the price is changing so much. And so they don't, that's a risk that people have to deal with. So as you said, maybe there's some people who would want to actually translate that back into US dollars right away, just use Bitcoin as some means to take a payment, but then immediately move it back into US dollars. So yeah, there are going to be people who do that. But let's take the case of just somebody who is using Bitcoin and sort of the Bitcoin, let's say the Bitcoin is now, it's a Bitcoin economy and people are happy to hold on to Bitcoin and exchange Bitcoin. It's just another money, right? So, again, if you want to, if you do want to translate to dollars, again, you probably have your Coinbase account and you move it, and then you use your exchange there on Bitcoin to sell your Bitcoin and then have USD that then you have in your bank account as USD. So and people use other there's some sorts of coins that are meant to represent value of a dollar, so maybe they'll use that. But anyway, if you're really being conservative, you there's something called Tether which people use, but if you're really being conservative, you probably just want to have it in your bank account as USDs. But okay, and assuming that you just want to be in you jumping into the Bitcoin economy, you just don't care if it's all Bitcoin, and so you're just using Bitcoin as Bitcoin. What happens is there are a couple of things. One is if you're just using Bitcoin itself without Lightning Network, it's just a simple payment from person A to person B. There's a transaction that takes place. There's there's an address that you can represent with a QR code. And so, say you have a wallet that's tied in with your Bitcoin, and you can read the QR code, and so you get the address to send it to, and so I went to a coffee shop in Palo Alto, California. I was so thrilled to buy my first latte there many years ago, and they had just a little QR code that was there, just on this little stand, and so I just used that address to send there was the address I sent my Bitcoin to, and I was able to get they were able to see that it arrived, and they gave me the coffee. Now with Lightning Network, it's a little bit different. Instead of payment, you have there what's called an invoice, and so there's a little bit of a difference there with regard to how that all works. There are ways with Bitcoin to have some sort of sense of there's one way of doing something like this, but without getting into detail, with Bitcoin, there's really just this payment from one person to the next for your simple transaction. With Lightning Network, there is an invoice that you can create, and so it's a little bit different.
Got it. That makes sense. Yeah, I feel like there's a lot of more merchants nowadays who are accepting Bitcoin because not just because of Lightning, but just because of so many other factors where they believe that Bitcoin and other cryptocurrencies are sort of going to be the main, well, not the main, but at least one of the key players. And especially it's important because as we become more globalized, having Bitcoin on yourself and being able to use that no matter where you are, there's no exchange rate per se with any other currencies. I think you've really universalized a lot of the transactions that you can do, merchant to merchant and consumer to consumer.
Yes, I mean, just think of like all sorts of business models you can have organizing a company where you're paying everyone in Bitcoin and not having to worry about all the details of foreign exchanges and stuff. It's just everyone's happy taking the Bitcoin and they use it however they would like. But it's just this easy way to remunerate your employees or whom you're working with, paying for goods and services in a mutual way.
I want to, I think we're sort of hitting the half 90-minute mark here, but I'm really enjoying the conversation here. But I want to sort of, uh, sort of switch gears a little bit and figure out a little bit about your technical background, because I know that you've done a lot of playing around and development. I think you started in Java and a few other languages as well. What about, with the Bitcoin stuff that you're doing at the moment? I know that you're delving into a lot of languages, everything from Scala to Rust and Go. What um, things do you see in that space? Why um, do you feel that it's important to explore a lot of these languages and what they can offer to the community?
Well, I would say, apart from Bitcoin, I mean, Bitcoin is really my focus. And so, in fact, one way I'm sort of learning languages is to implement Bitcoin libraries using these languages. So I'm learning Bitcoin, but I'm also learning those languages. And so I've done a little bit with Rust and Scala so far on those, and I plan to do it with Go and Elixir and all sorts of different things. And just, it's a way of learning. And after you learn from programming Bitcoin, the book that Jimmy Song did, I mean, it's sort of an interesting, you get a knowledge of how to do it all from scratch, and there are implementations, like there's a Go implementation of Bitcoin, which now that I know Go, I can look at and understand. With Mimblewimble, I really wanted to understand some of that and be able to contribute if I really got interested. And so happens it was in Rust, and so that's when I realized, okay, maybe I should learn Rust. So that's when I learned Rust. But I am not so interested in Mimblewimble anymore, but I'm interested in Rust. And anyway, I think. Let's see. So to answer your question, I think one thing that, again, apart from Bitcoin, Bitcoin's sort of a medium with which I'm learning things right now, apart from my inherent interest in Bitcoin. But just forget Bitcoin for a moment. I came, I'm originally from San Francisco, but I spent some time in Minnesota, and there Java. I just lived and breathed Java, and then moved to New York City again, Java, and that was fine. And I moved to the Bay Area, and for some reason, I'd go to these hackathons or these gatherings, where this one. There was a project. I don't even remember these projects which you go to and you just sort of get together with people, and then it's like, oh, hi, I can contribute with Java. And it's like, oh, well, we're using Python or Node. I mean, it was really not the cool kid on the block anymore, So I realized, okay, I got to do something. I mean, just apart from anything else, I mean, I just had to learn some other languages to be able to fit in and do some fun things with these other projects, that people were talking about so I learned Python. The last job I was working at, I used Python, but I also had been interested in Scala, and I'm super interested in Rust. I really like Rust a lot. And what I find is that also as I go, it's very handy because there are various technologies you learn, and these textbooks or tutorials will go through showing you these new technologies, but they'll tend, some of them will go through it. Like our reading group, we went through a Go tutorial, and then protobufs and gRPC. We went through a book called gRPC Up and Running, and I mean, some of those tutorials do try to go through various languages, but oftentimes you'll have a textbook where it's Go, and so to go through and understand the technology, they're using this particular language. So it's very it's important to have more of a polyglot approach. I mean, I'm interested in the polyglot approach because I think distributed service architectures are very interesting. I mean, I still think modularization at the for monoliths is very important too. But I think when you do have distributed service architecture, it's very interesting to use the language that's appropriate for whatever you're doing and the various services. So I'm interested in that from that aspect. But I think also just pedagogically, for example, there's this really interesting book that I just acquired. Paying electronically, not by Bitcoin, just my old credit card. I bought this book called Building Git, which is trying to go through the internals of Git. And so I think that's sort of fascinating. I was just taking a course on O'Reilly live online training with Venkat, I forget his last name, but super teacher. And he went through some of the internals of Git. And I was fascinated. So I've bought this book, and I'm sort of hoping our reading group will go through it. However, it's in Ruby, so I don't know Ruby. So again, I mean, it's sort of like you part of the learning is just for fun. I love to learn, but part of it is just because just to be able to go through and learn interesting things. People are using different languages.
How important is it to learn different languages nowadays? I think,
Oh, I think.
obviously when you're growing up, right? You mentioned Java was sort of your bread and butter,
Oh,
but
yeah.
eventually, you get to be exposed with um, languages that are advantageous and disadvantageous between those languages. But nowadays, there's so many out there, right? So, what sort of advice would you give people who are starting to learn languages, right? Why is it important? Why is
One
it?
thing I'm doing is I'm have a little notebook where I'm like, and in fact, I think there should be a book on this. Maybe there's a book out there somewhere, but one thing that's sort of something is that all these languages, one of the hard parts is they're all, a lot of them are very similar in some senses. So, it's easy to pick up the one from, knowing others. But that's part of the problem too, is that they're so similar. There are these little differences, and so you get back and go back and forth. It's like, I have to remember this little detail over here. It's a little bit different, but it's mostly the same. But I'm sort of putting together a notebook of like, okay, here's Elixir, here's Rust, here's Go, and the little quirks that each one has a little bit. And I'm just trying to record that, but I'm surprised there isn't a book on that already, where you kind of have some reference, so you can sort of shift gears from one language to the other, and if you've been working on this other language for a while, you switch back into a gear with this other language, and you sort of remind yourself, oh yeah, it's a little bit different in this aspect. So I don't know. I think that's part of the challenge is to be able to deal with those details. But I don't know. I think it comes sort of naturally. It's like learning a different foreign language. I think I mean, French and English. I know French fluently and went to school there and all that. And there's similarities and all that, but you just sort of get in the mode. And there's this. What's interesting too is I think there's sort of a community. There's a community aspect that's different to each of these languages. Clojure, they have a very different community from Scala. There's a mentality and there's a sort of an attitude. All sorts of different things that are different between the communities, and so it's really interesting to see the different communities and. They all have a little bit different philosophy, and so I don't know. I just think it's sort of much like I was an exchange student, and sort of it broadened my horizons. In a lot of ways, learning these different computer languages broadens your horizons because you start to be able to think in different ways.
Yeah, no, I completely agree because, you know, if there was only one universal language, then I think it would be pretty boring. And
Yeah.
I think the fact that there are so many languages available now that people can start to pick up and learn very easily, not just buying a book, but just coding away, looking online, doing online courses. I think it's becoming super important and obviously very, very valuable to people who want to enter the industry, because
Mm-hmm.
the more languages you can showcase on your resume and like, I've done this and I've done that, I think it's become I think that's sort of the norm now, where a lot of people are testing languages, not just your Java and your C and your C++, but like Go and Rust and
Yeah.
Scala and all of these other languages.
And I highly recommend doing an open source project. I mean, where you are, showing. I mean, again, initially when you're working with a language like with Rust, I mean, initially you know, you're going to go through a learning curve, and with Rust, you're going to go through a big learning curve. Man, Go is very simple. Rust is quite a learning curve, to my mind. And so go through that learning curve by doing an open source project, and eventually it'll look better and better, and all that.
Yeah, no, I think I agree with that. And the reason I wanted to ask you that question was because you are such a polyglot, and you are familiar with numerous amounts of languages. But I feel like your thought just came back to you. Why don't you go ahead and
Yeah.
say?
Okay. So another thing that I think is driving this is of course, there comes a point where concurrency becomes a very important thing. Is through my career, it really became something that became more and more important. And I think there's certain languages that are more geared to handling that in a much more sane fashion at compile time, and that's one reason I'm so interested in Rust. There's another language which very few people know about, but one great a couple of really interesting resources for people learning all these things. O'Reilly has a wonderful subscription model where they have online training, live training with teachers who will teach you various languages or technologies. I think that's a really good bang for buck. But there's also something I'm starting to play with for learning Elixir, and also another language which is called Pony. Pony is something that's akin to Rust, but it sort of takes it to another degree with regard to concurrency. And Grox.io is the one place I've seen where they have some teaching on Pony. It's very few people. There's very few resources with regard to Pony yet. But again, I think my interest there is really with regard to making sure that things are secure and working well, and that things are caught at compile time. And boy, Rust is wonderful in that respect.
What would you say that Rust is the language that you're gravitating towards at this moment in time, or
yes.
do you enjoy Go more?
I love Go. I mean, in fact, I'm one of the guys in the Rust. Again, the Rust thing. I sort of was looking at the thing, and I was like, "Oh my gosh, I don't know. I need help on this, going through this thing." So I started a reading group on Rust. In addition to the Bitcoin reading group, I said, "Okay, we'll do Rust now too." So we went through two really thick books. Rust programming language and programming Rust, the O'Reilly book, and both of those are thick and dense. And we went through all these discussions. Every chapter was just full of interesting information and but again, really dense. And you learn all sorts of stuff through that. And through a reading group, it's great because then you can really, you think you know it just by reading, but when you discuss it, it's just another level of learning. But one of the guys in the reading group was saying, Go is really cool too. And what's the big thing about Rust? And Go is so cool. And so anyway, he eventually was recommending that we do the gRPC stuff, which is really, I think, interesting. And so I'm glad I've done that. And to do that, you need Go. So we started with the the Tour of Go tutorial. And it's just so simple and easy. And I'd gone through a book on Go before, but just going through the tutorial and going through some of the examples of gRPC. And now there's another book I really want to go through, writing an interpreter in Go and writing a compiler in Go. So if anyone wants to go through these books, please let me know. We did another one called from NAND to Tetris, another sort of where you just go from scratch with regard to NAND gates, and you build up a computer that can run Tetris. It's a really, if you go to nandotetris.org, really cool. There's a book and everything. And so we've gone through that. I love that sort of stuff. So again, for me, that was just curiosity. I just wanted, I actually had, before economics, I was doing applied physics at Stanford and did quantum mechanics for a couple of years there. So I know quantum mechanics. I know how a NAND gate kind of works because I was solid state physics. And then I was doing Java at the other end. And so it's been fun to kind of learn all the mysteries of all the black box in between. And so just in terms of curiosity, it's sort of fun to do that too. But I think the need for working, for doing things in current fashion and managing that through a compiler that can check on things that more readily than, Java has its strengths, but I think with Rust and with Pony, I think you'll when security is very important, I think, and speed. I think those will. I'm not sure about Pony how fast it is, but I know Rust is very fast. So
I think that's a key, right? Like these languages, there's no one language that rules them all, right? Mm-hmm. There's always going to be there's going to be good things about the language, and there's going to be not so good things about the language, and that's where other languages sort of have their strengths, right? And this is sort of comes to your point about distributed service architecture, why it's important to have a polyglot environment and have
to be able to independently scale.
Yeah, exactly. So you can independently scale, but also when it comes to security, if you need to develop a security service, you choose a language that is more prone to developing providing those strengths, right?
Exactly.
And I wanted to sort of have some closing thoughts for you, and I think for the most part, what you've done over the years is really amazing. But the fact that you're continually learning and learning different languages, and I think people need to understand that, once you finish with school and once you finish with college, doesn't mean that your learning has ended. I think that's just the start of your learning experience. And so maybe from your experience, explain to the listeners why continuing to learn is so important.
Well, I think it sort of goes in both directions in a lot of ways because, I love to learn just inherently. So I gravitate towards software because, boy, you constantly have to learn. And so for me, that's wonderful. That's a challenge and I love it. And so I love that aspect of software. But yeah, it's
Right.
important with software, I just think of what was going on 10 years ago. I mean, you learn stuff, you use it, and then, you turn around and there's something new. I mean, it's just how it is.
Yeah, I agree with that. And, software is one example where if you really want to be up to date with all the latest technologies, you have to continue to learn.
Mm-hmm.
And that's something that people have to come to grips with if they want to enter the industry. And that, I guess, it doesn't go, it goes well with software, but other aspects, because, I think a lot of the industry now is phasing out monotonous jobs. I think all of them are being monotonous, automated. And I think creativity is where it comes into play now. And I think being creative is a continual learning process. You have to
Yes.
come up with new ideas, be innovative in different areas and spaces. And I think, to your point, what you've done over the years, learning from Java to different languages, and also having interest in Bitcoin, but also alternatives to Bitcoin, and just having that sort of growth mindset and
Mm-hmm.
learning as much as you can. I think that's valuable and very important.
And sometimes you don't really understand how it'll all fit together. I mean, you kind of look ahead and it doesn't make much sense. But then later on, you look back, oh, hey, yeah, it made sense. Somehow, if you follow your interests, I mean, not always, I'm sure, but, at least with my experience, somehow it seems to fit together in some way.
Yeah, you sort of join the dots at the end of the day. Tell us about your reading groups before we sort of finish
Okay.
off. What are you? And you can name all the reading groups, and I'll put the links into them below, or if they want to get in contact with you. But tell us how you got
Okay.
started with your reading groups.
Okay, and I'll give you a couple links, and there's some links too. I create some indicators for Bitcoin Trading View charts that people can know. I do two indicators that sort of help you with the long term or the short term price movements and medium term price movements. If you look at the weekly on that, anyway, I'll share those, and then but with regard to the reading groups, it's called the Los Gatos Reading Group. Los Gatos is the town I live in here in California. Again, 50 miles south of San Francisco, and so it's named after was San Francisco Bitcoin Reading Group, but then I moved, and here I am, Los Gatos Reading Group, so if you go to meetup.com, just look up Los Gatos Reading Group, and you'll see we've done, I think we're right now we're doing a book on advanced Java, modern Java in action, and then also we're going through this Lightning Network book. We're just finishing up with the gRPC. There's a list of books that we're looking at doing in the future, like on Sunday evenings, maybe Thursday evenings. My Wednesdays are taken up with Bitcoin at Santa Cruz Bitcoin Group, but Monday and Tuesday are other nights where we're doing these two other reading groups. So trying to fill up the week, and so some of the things that we might do is Elixir. I think is sort of really interesting, so that'd be sort of interesting, and also maybe doing the internals of Git. I think would be a sort of a fun reading group to go through that book. There's also another tutorial on that uses Python. So anyway, Los Gatos Reading Group.
Perfect. What was the impetus of starting the reading group?
Well, again, it started way back when with the first of all, I had the wonderful experience at the Stanford Bitcoin Club doing peer-to-peer learning. And peer-to-peer learning, by the way, is let me just sort of mention how we proceed. Very interesting. What we did at Stanford Bitcoin Club was we went through this book chapter by chapter. Each time we met, we went through a different chapter. So everyone reads the chapter before coming, but everyone also has an added responsibility. People pick out a different section that they're responsible for. So as we go through the chapter, there's somebody who is presenting that section of the chapter in their own words. It doesn't have to be anything onerous. They just sort of, go through and express what's in that section in their own words, and then leave it, open for discussion, questions, and then we move on to the next section. And just that simple way of going through peer-to-peer fashion is really remarkable, because there's so much you get just by articulating what you've learned. I mean, I really would I urge people to sign up for as many sections as possible, because again, it's just like you learn so much by articulating, and then the discussions that happen are really wonderful, because you think you've covered everything in your own mind, but there are these questions or aspects of the topic, the subject, which other people bring out, and you have these amazing discussions out of nowhere, and you learn so much more through that. I think through this technique. So what happened was, with Jimmy Song's course that I had taken, this 2-day course on his programming Bitcoin from scratch, where he used Python to build everything just from ones and zeros, really showing how to make these transactions, how to go through the elliptic curve cryptography. I mean, we learned all that, really from scratch. I mean, we didn't use a library for that. We created the elliptic curve code. And so very, very interesting and fun. And so anyway, number of us wanted to go through that at our own pace together. And so we began there. We went through mastering Bitcoin, programming Bitcoin, grokking Bitcoin. And then that's when I started also becoming interested in other languages. So the reading group expanded into doing Rust and other things. And so
awesome.
And it's just a matter of people meeting on Zoom. We tried various different means of interacting, and Zoom proved to be the best.
Well, which is cool now, because you guys are virtual. You don't have to be in Los Gatos to join.
Exactly. We've actually met in person once, and sort of discussed sort of what the next book was going to be, and sort of socialize. And we'd like to do some hacker gardens, where we did do one hacker garden in Rust up in San Francisco once on this beautiful rooftop. It's just a beautiful setting. So occasionally it's nice, for people who are local, to have an occasional meeting where we do something, and maybe, again, a hacker garden or something like that. But for the reading group reading activities, we have people, there's somebody from Australia who, has participated, and, other people from different locations. So,
Nice. That's really cool, and I hope everything is gonna go well with the reading group and everything that you're doing so far. But I really want to thank you again, Casey, for joining the podcast and sharing your insight into everything that you've been doing so far. But also get to explain a little bit about Bitcoin, crypto, and all that stuff. So thanks, Casey. Appreciate it.
Yeah, my pleasure.